Alright, moving on with our solutions for the mastery quiz number 2 review. We have some word problems here. Read through this and figure out what your variables are going to be, and we'll continue on there. Okay, so I've chosen G to represent the cost of a single square foot of grass, and I to represent the cost of a pot of ivy. As I read through these, I notice I have two statements here that give me totals. And those actually just translate right into equations. You have a total of $108. And that's made up from 4 square feet of grass. So that's 4G. And 11 pots of ivy, so 11I. And there's my first equation. The next one totals out to be $116. And that comes from 12 square feet of grass, so 12, and 7 pots of ivy, so 7I, and doing the 7 times I and all that gives us the totals for our the costs. And now that I have this lovely system, all I need to do is solve it. I'm going to start here. Let me square that off. I'm going to take my first equation and just times by -3. Because I want to go for elimination. I know 4 times 3 gives me 12, so I get my equations to match up. I get -12G minus 33I, and then 108 times the 3 is going to give me -648. So now I have my new first equation. I'm going to take these here and just add them up, because that'll get rid of the G part, and you'll get -26I, so 7 minus the 33 gives you -26I, and then on the right side 116 minus 684 is going to give me -532. And now we should get the I by itself by dividing both sides by the -26. And we'll get I equals, hold on a second. Alright, so I figured out where things went horribly wrong, because I noticed that this wasn't a whole number, and she bought pots of ivy. She didn't buy parts of pots of ivy, and it didn't make sense. So notice here, this number, I had 500 something. That's not what 108 times -3 is. It comes out to be -324. And so when you add those together, you'll get -208. And then when you divide that by the -26, you'll get 8. So she got 8 pots of ivy. And once you have that, you can take that number and put it into one of your equations. I'm going to put it into the second one. So I got 12G plus 7 times the 8 gives me 116. 7 times 8 is 56. I'm going to subtract 56 from both sides. And that's going to give me 12G equals 60. And when you divide both sides by the 12, you get Y, or G. The amount of square feet, the cost of the square foot of grass is going to be $5. And so, there we go. Moving on to 20, read through that, get familiar with it, and figure out what variables you're going to use. Okay, so reading through it, I decided I want T to represent the cost of a student ticket, and R to represent the cost of a senior ticket. That's what we're trying to figure out. And those two sentences I underlined up in the problem are where I'm going to get my equations. The first one says I'm going to get a total of $35, and that came from 5 senior citizen tickets and 4 student tickets. So that's 5R and 4T. And then my other one got a total of 76. And that came from 12 senior citizen tickets and 8 student tickets. Okay, so there's my original system. I'm going to work with that. make it so it doesn't cross out my words. And I notice that the t's are close to being matching. If I just take the 4 and times by 2, I'll get the t's to match, and then they'll add out. I'm going to multiply the entire first equation by -2, and that's going to give me negative 10r minus 8t, and then 35 times -2 gives me negative 70. And now that I have that, I can add my new equation here and my second equation from my original system to get 2r equals 6. So if you divide both sides by 2, you'll get the cost of the senior ticket to be $3. And once you have that, you can take that and plug it into one of your equations for r. I'm going to put it in the original first equation to get 5 times 3 plus 4t equals 35. 5 times 3 is 15. And then subtract 15 from both sides to get 4t equals 20. Divide both sides by 4, and you'll get the cost of a student ticket to equal $5. And then that brings us to the systems of inequalities problems. Read through that and kind of think about what inequalities you're going to use. So I went through and kind of underlined the important pieces. This first statement up here says you can't spend more than $36. So one of our inequalities is going to be less than or equal to 36. And that cost comes from the cost of bags of chips and bags of candy. It's $2 per bag of chips, so that's going to be 2x, because x is the number of bags of chips, and $3 per bag of candy, so 3y. Add them up. When you get your total, it needs to be less than or equal to $36. And then my other inequality says I need to have at least 10 bags of snacks, so I need greater than or equal to 10. And that's made up from x and y. And those are just the totals, just number of bags of chips, number of bags of candy. If you add them together, you'll get that inequality, which needs to be greater than or equal to 10. Moving on to the next part, we're going to graph that inequality, the inequalities, and then figure out some solutions that would work. So I copied my system here on the right side. In order to graph this, I need to either A, figure out my x and y intercept, or B, get it in slope-intercept form. What I'm going to do is I'm going to get my x-intercept just by taking 36 and dividing by the number in front of x, which is 2, which is going to give me 18. So there's my x-intercept. The y-intercept comes from just taking the 36, the number on the right side there, and dividing by what's in front of the y, which is 3. So my y-intercept is going to be 12. So I have an x-intercept of 18, which is right here on my graph, and the y-intercept is 12. I have those. This one says it can be equal to, so I'm going to draw a solid line there. And it says that it needs to be less than, so I need to shade down below my line, like so. My other inequality, instead of getting the x and y-intercept, which are both 10 by the way, I'm just going to subtract x from both sides just so you guys can see what it looks like when it's a little bit different. You get y greater than or equal to negative x plus 10. So I have a y-intercept of 10. The slope is negative 1. So if you go down 1, right 1 on your graph, it's going to go like so. And this one can be equal to as well. So it's going to be a solid line going like this. And this one says greater than, so I need to shade up above my line, which gives me a shaded region right here in between these lines. And that's where all the answers are. And you can pick all sorts of things for possible solutions, just any point that's in there. Like there's a point here at 6, 6. So that'd be 6 candies, 6 bags of candy, and that's hideous handwriting, 6 candy bags, and 6 chip bags. And you can also pick like 12, 0 here, So since X is the number of bags of chips, it can get just 12 chips and 0 candy bags. Or you can come right here, and there's another point, that's the point 10, 4. So that's 10 chips and 4 candy. And there's a lot of different points in there that you can choose from. Let's get this last one in hopefully a short amount of time so we can just fit it on this last video. So here's this read through, make sure you know what's going on. So my first inequality is going to talk about this $750 worth. You need to get at least $750. So you need something greater than or equal to $750. And the costs, the sales are going to come from selling these tickets at $3 per single person, so 3x, and $5 per couple, so that's 5y. Add that up. This total needs to be greater than or equal to $750. And my other inequality is going to come from this other statement where it says there needs to be no more than 400 people. So we need less than or equal to 400 people there. And the single people, if you have that number, that gives you how many people from that group. And then the y part is the number of couples. Well, there's 2 people per couple, so you have to get 2 times the number of couples to get the number of people from the couples, and so that's where my other inequality is going to come from. Let's switch to the other part, and we're going to graph it and get some solutions. So in graphing these, I'm going to just get the x-intercept and the y-intercept for both. If you want to get the x-intercept, take your total on the right side and divide by the number that's in front of x, which is 3. So if you take 750 and divide by 3, you'll get your x-intercept, and if you want to get your y-intercept, you're going to take 750 and divide by what's in front of the y, which is 5. And so when I do that, I'm going to get 750 divided by 3, which will give me a x-intercept of 250. And then 750 divided by the 5 is going to give me 150. So now I have my 2 intercepts. I'm going to plot both of those. I got 250 and a y-intercept of 150. This one says it's greater than or equal to, so I need to use a solid line. And it says greater than or equal to, so I need to shade up and to the right. Like so. And then my other inequality, I'm going to get the x-intercept the same way by taking the total and dividing by the number in front of x. If there's no number there, that number is 1. So my x-intercept is just going to be 400. And my y-intercept comes the same way. 400 divided by what's in front of the y, which is 2, which is 200. And now I have my intercepts. I have the intercept of 400 for x and 200 for y. This one says less than or equal to, so since it's or equal to, I can make it solid, just like that. And less than is this away. And so my double shaded region is just like the last time between the 2 graphed inequalities. And once you have that, just pick some points and translate what those mean in the context of the problem here. Like you can do 300 couples. Not 300 couples, just kidding, that's way too many. You can do 300 single people. You can do 200 single and 50 couples. And you can also do just like 150 couples. And you'd be good to go. And that's the final solution for the Mastery Quiz number 2 review.